mi chiamo Kateryna, sono felice di vedervi tutti. I tried this a lot, but unfortunately I'm still practicing. Thank you so much. Yeah, so basically just to make sure that I didn't say something inappropriate. Hi there, everyone. My name is Kateryna. I'm so happy to be here, so happy to see a lot of people actually interested in the AI in the Kubernetes. Because especially today we have extremely exciting topic for me, for example, because we're going to host our AI Kubernetes model. And mostly we're not only going to talk about how, we're also going to talk about why and what for, because in the end of it, we always want some benefit, we want something good from development, so that's what we're going to do today. And of course, I'm going to show you how to take your model to some cloud so you can brag about it to your clients, friends, or whatever. So let's start. And oh my God, it's front screen. So here we are. So as I said, my name is Kateryna, and I also want to meet you. Please raise your hands if you are working with AI or you are passionate about AI. I want to see your faces. Yes, yes, yes. You know, like a few years ago, it wasn't so many people who raised a hand, but now it's much different, so I'm so extremely happy about it. So also please raise hand if you know what is Ray. Have you ever heard about Ray? No, but please don't get away, don't get scared. I will explain everything, and hopefully by the end of the day you will be extremely passionate about Ray, because unfortunately they don't pay for me for that, but I'm still advocating a lot for it. So my background is software engineering, and recently I did a lot of DevOps stuff. I work with e-commerce, so it's a bit boring stuff, but that's where I started to understand the numbers and started to look into simpler solution for less cost. So that's actually why I'm here today. And also, most importantly, I love NLP. I do a lot of NLP on my side projects, and that's actually where story begins, because you know what they say, with no pain, there is no gain, and trust me, when you deploy the AI models, it's always pain. And I extremely love this picture because this actually totally explains what's happening in the domain of AI deployment, because when you have your model nice, fun, and extremely exciting, you want to show it to the client, you want to show it to the people around, but how to deploy it. And you start to Google around, you start to try to find some solutions, and then you understand that all your pretty model need to be changed brutally to just meet one of their sources that you can do. You can do Vertex AI, you can do ML flow, different stuff, but that requires from you a lot of changes on your side. So you cannot just like, oh, I'm doing Vertex AI, I will do it in 5 minutes. No, it's not possible, because you will need to change your interface, and etc., etc. And that's exactly the place where I thought like, well, maybe it's not the best idea, and I just want my model in the cloud tomorrow. I don't want to change my code, I don't want to adapt, I just want somehow it get deployed. And it sounds like something miracle, something magical, but trust me, it's possible, and that's what we're going to do today. And we actually have a lot on our plate today, extremely a lot. So if you're noticing I'm going into Eminem mode, that's only because we are close to the demo and I'm trying to be as fast as possible. So first of all, what we're going to talk about, we're going to talk about challenges in AI domain. Then I will try to convince you that Kubernetes solves these challenges, hopefully successfully. And after that, I will show you how to befriend your AI pipeline with Kubernetes. And of course, I will tell you about Ray, this magical force that we're going to talk about a lot. And in the end, you'll see live demo, because otherwise it wouldn't be fun. And of course, you will receive some run books so you can experiment yourself. And let's start with getting to business. But before, please meet my alter ego. It's a toxic cat. I'm usually extremely critical to myself, and this guy helps me to work with my anxiety. So it will ask all the dangerous questions about my presentation, so you will see him a lot. And first of all, we are starting to talk about domain and etc. What's the pain point when we are talking about deployment of AI model? Actually, there's a lot of pain points, but most of them are like in 3 sources. First source is cost. Whenever you talk about AI, it's always money, it's always X3 in the cost, how you usually do, because you have a lot of data, you have a training process, you need to scale as soon as possible. And it's a second problem, because Of course, when we do e-commerce, we also want to scale as quickly as possible. We're going to get these resources and then release it. But in AI, it's even more critical because we'll have a lot of idle time. When we do, for example, continuous training, there hell a lot of time. We're just waiting for the next training job to come. So that's the second point, actually scaling preferable to zero, a lot of days. And of course, the third one is also a classical one. It's a strong bound. It's what I'm saying before, that if you wanted to start with your cloud, with your deployment on, for example, GCP or other sources, you will start with something like Vertex AI. It's extremely on hype, but it will make you to stay in their ecosystems. Once you made the decision, you cannot just jump off. You cannot just switch to AWS or Databricks or whatever, so you will be bounded to the Google Cloud provider. And as much as I love Google, it's not acceptable because you always want some freedom, surely. And the fourth point is a bit of controversial. I'm ready for Rotten Tomatoes, but let's be honest, we just recently decided what is actually DevOps should be. And when we're talking about MLOps, there is a lot of fights about how it should look like, what steps we should put in, what tools we should use. So MLOps is difficult, and a lot of people claim that it's not DevOps at all, and blah, blah, blah. So we're still not sure what to do with it. And here comes our magic soldier. Here comes the Kubernetes, and there is exactly 4 reasons why Kubernetes strikes through the bingo for all of these problems. Of course, you heard about this hype title, write once, run everywhere, and that's exactly solving our problem. We can put our module into the container, and anytime we can move to another provider more easily if he was, for example, trying with Vertex AI. So I think that's obvious. That's exactly what we want to do. Secondly, Kubernetes was designed and built to scale and manage. So exactly our problem with scaling can be solved much more easier with Kubernetes than with other tools. And you can actually control the scaling process because, for example, in Vertex AI, you usually rely on the provider. And here you're completely in control. Third point is amazing ecosystem. I think everyone integrates with Kubernetes one or another way. So I think it's obvious. And the fourth point, of course, it's when you actually know what to do with containers, right? We know how to build CI/CD for containers. We know how to manage them, how to deploy them. And let's be honest, when you are starting a new project, it's much more easier to start with containerized application already for ML than to configure something with Vertex AI, because you already know how to do it, and we get used to it with time. So basically, all 4 points are gathered together. And now I see in your eyes that some of you like, okay, well, maybe she's onto something, maybe it's true, I'm starting to convince you, but I actually promised you a lot already, right? Because you thinking, well, maybe it's really gonna work. I'm not sure it's this easy. So I promised you everything, but let's firstly try to check if it's really true. And we're gonna start with real use case examples. So for example, let's imagine we have our nice model, it's already trained, it's already tuned, and all shebang and black magic is done. That's exactly the point of interest, when we have our model pre-trained and ready to be integrated. What we usually do, we usually build some simple interface around it, some API with fast API Flask. It's not also my interest today, so you can do it quite easily. It's simple server. And then you can just put it container as usual, you can build it, and you can deploy, for example, some Docker Hub. Sounds good. Okay, sounds reasonable, sounds well. But unfortunately, it's not this easy. Unfortunately, you cannot just simply do it because AI still have a lot of challenges that not common, for example, for general e-commerce apps. And one of these challenges is actually distributed processing. Distributed processing is one of the help points, especially when you do training, because you need to control it, you need to properly distribute the data, you need also distribute the processes on a few machines, probably share within some global context, and etc., etc. Of course, if you're guru of Kubernetes, you can try to do it yourself, but it's a bit painful and it's not matching our concept to be done in one day. So it feels like we want some middle guy between our awesome model and Kubernetes to actually manage the stuff and for us to focus more on the development itself. And thankfully to the God and to forces and to developers, we actually have this resource, and it's Ray. And that's exactly the point where I'm starting to advocate as fast as possible, because Ray, in my opinion, is one of the most hyped and underrated tools still in the ecosystem of AI, because it does awesome things. Basically, what is Ray? It's an open source framework for managing the distributed processes, but on extremely high levels. So it uses Python API to allow you to manage distributed process on the level of the Kubernetes. How cool is it? So basically, Ray was designed for developers who maybe not as much experienced with the distributed processing, but you still want to do some cool stuff. And it will provide for you orchestration for the processes, also scheduling of the jobs, also some primitive fault tolerance, primitive unfortunately, but we still have here, and of course auto-scaling. So all of that wrapped in a Python. How cool is it? And it's completely open source, even better. A little bit more on how it looks like. Ray is actually extremely lightweight. So for example, let's imagine we have our nice Ray library. It will stand between us and our cloud provider, and it will manage all the processes on the level of the Kubernetes. That's where the magic for distributed systems will go. But it's only Ray core. What else Ray provides, it's also a lot of different libraries that you are free to not use, but it would be nice always for you. They have Surf that we're going to look today. It's about hosting and managing your model when you're deploying. Then they have Tune for tuning, obviously, Train, and for data, they have also Ray Data. And trust me, if you're going to do AI or ML or whatever, you will benefit in cost hell a lot if you're going to use Ray, because it solves a lot of common issues. For example, Ray Data that we're not going to touch today, unfortunately, because it's for training mostly. It allows you to reduce the cost of processing the data by streaming in batch from, for example, some cloud storage to your training job. So you're not paying for cache. You don't need to load everything into your memory when you're processing it, but you can do it with streaming. And trust me, it's like a lot of benefit when you are doing like terabytes and terabytes of data. So that's just one point where you can benefit from it. So let's look a bit closer to the Ray core. Probably if there is Python developers, can you raise a hand who is Python developer? Okay, so you need to do something like that, because it's unfortunately extremely small, but just trust me, that's how Ray core allows you to integrate with distributed processes. And that's the pretty of it, because let's remember how usually Python works. We have functions, we have classes, and we have variables. When you want to wrap it up and use in the distributed system, all you need to do is to add the annotation for Ray to know that it should be transported and run it remotely, and it's all. That's all the magic and pretty things that you need to do. For example, how you can transmit the usual function from Python to the task that will be running remotely and manage it on few machines. You just need to add the annotation Ray remote, and that's all. After that, you provide in the configuration on how much machines you want to run it, how you want to distribute it, what the parameters you can add, and that's basically all. Now your task completely ready for the deployment. So from Python perspective, it's quite easy. That's what I said. When I said that Ray is extremely lightweight, it's really this much. I'm not sure if you see it, but on the second screenshot, you can see even the class, model API class, that we can share between few instances. You even can define how much of GPUs you're going to use. So you're going to use 4 GPUs to distribute this exact class. And that's all what you need to do. And other stuff will be handled by Ray itself. Also, Ray provides configurations for immutable variables that can be across different clusters and globe. But I mean, like, it's also pretty simple. It works similar to the collection API. You can just push your variables inside of the shared thread. And after that, it will be available in any part of your code on any machine. So that's actually, I mean, like, for developer, it's extremely simple. You can still focus on your code, but ignore all the distribution part. And that's the next point where you're going to stay a little bit. So you remember when I showed you this slide, we have Ray core, so that's where the magic for distributing going to be. But we also have Ray Surf, and that's the library that will allow actually hosting your model. So you will laugh, but again, what you need to do a Ray Surf, you just need to add the annotation with information on how much of GPUs you want to use, and that's all. Now your project is wrapped into Ray and safe to deploy in the Kubernetes and then later in the cloud. So that's also pretty of it. For example, if you have your model, you have your code, and you don't want to change anything, Ray is perfect because it will work as a wrapper around your model, and you don't need to change your code at all. You just need to annotate it, and that will be fine. So that's a like a lot of pressure and a lot of releasing pressure actually for developer and for whoever gonna deploy to the clusters. And well, you probably also again listening to me. If you're still with me, you listen like, well, sounds good. I just can add annotation and live happily, but unfortunately, it's still not true, because well, we managed to turn around the distribution and we managed to give it away to Ray, but still we have small issue with scaling because Ray itself, it's not operating with Kubernetes. And that's a bit tricky because you still need to scale, preferably need to scale from 0 to a lot of machines. And how you can do that? It feels again that we need a middle guy in between Ray and between some cloud. For example, we can use autoscaler for GCP. What we're gonna use here? We're going to use Kubernetes operator. When I said that everything integrates with Kubernetes, I wasn't kidding. Basically, Ray also do so. And it allows you to have Kubernetes operator that will manage resources in similar way as any other operator do. So basically, that's the middle guys that will do health checks, creating pod, deleting pod, observability, and etc., etc. And Kubernetes operators is actually pretty simple. I'm telling the word simple a lot, but it's how it is. So you have only 3 types of the resources here. First resource that you have, custom resource for Kubernetes operator, is Ray cluster. That's where all our jobs and all our hosting of model will live. And that's basically where all the magic on scaling gonna do. Also, we have another resource. It's Ray service. It's combined resource that includes Ray cluster, so it can do scaling, it can do managing, but also in addition, it creates space for initiating the Ray serve applications. It's also responsible for the continuous loading, provides some features for zero downtimes, and also some upgrades on the high availability. And the third resource, unfortunately, we're not going to look into it today. It's for training mostly, but that's a Ray job that allows you to scale from 0 to whenever you want, because you can delay it and you can schedule it, and it basically works as job on your Ray cluster. So that's extremely useful for the training processes. And here on this moment, just to wrap up all the theories that we have, why Ray is cool and why you should consider to look into it. First of all, it's created for Python and it's extremely high level. You can still have your code untouched and just wrap it in the Ray modifiers. Secondly, it's extremely flexible, as you see. You don't need to implement what you don't want. You always just implement the core concepts for distribution, but other stuff you can ignore completely. Also, Ray takes on themselves all the logic for scalability, and in the end, Ray integrates with a lot of stuff. With AWS, with GCP, with other cloud providers. For training, it integrates with Hugging Face, with I don't even know, I mean, like all the stuff that you can imagine. Ray knows difference between GPU, CPU, and TPU, and you still happily coding with your Python stuff. So, I mean, like for Python developer, it's extremely handy. And now, finally, I can stop my Eminem mode because we get there, we get to the demo part. So that's actually where we're gonna do some fun. By the way, I developed the runbook for you, so if you are interested into doing some stuff on yourself, I also prepared for you all the commands, all the stuff that you need to know for deploying your model into the autopilot cluster. If you're not a fan of autopilot cluster, you can always use the general GKE cluster. I also showcase it here. And I did already pre-work, so I have my Ray cluster available and ready, so let's start with it. I will do some small comment to get the cluster credentials because I created it in console. And after that, we can look into code while our stuff gonna be deployed. So I'm gonna show how it's gonna work for you. Yep. So awesome. Now we're gonna do, you should see some code. And I will just run my general command to the, wait a second. As always, I'm in the wrong folder. Okay, awesome. So what we're gonna do, we're gonna deploy stable diffusion with the Ray serve. We will need for that few files. I will show you in a second which ones. And hopefully I'm in the right folder, of course not. I still need to go a bit further. This example is also available on GitHub. In the end of it, you will always can to look into code with more details. So while our configuration is applying, let me show what we're actually doing. So we will have our stable diffusion file. Basically, I'm just, as you said, I'm using Fast API for deploying it. I also have my nice class where I have all the logic for introduction of our model, for using our model. So basically, that's the magic happening here. What we're going to do, we're going to use stable diffusion to create some nice pictures. So as you see, it's pretty standard class of Python where we have init, generate, and simple stuff. And that's where our array configuration comes from. You see here self-deployment annotations that will show how much of replicas I want. I don't want to spend a lot of money, so I just added one replica here. And in the end, what you will need to do to use this server in REST-serve, you will just need to annotate it with information here. So you will have Ray actor on how much GPUs you want, and of course nums of replicas that you also want for this class. And in the end, you just bind in the pod. So it's pretty simple change for the Python. And now let's go to something interesting. That's actually configuration for a serve. Let's quickly walk through it so you will understand what's happening. So we are using the extension for Kubernetes with Ray. For version 1, we have custom resource of type Ray servers, and basically it's pretty standard with all the information that we have. Maybe only exciting part here, it's actually adding the Ray node basically as our head node in the container. Also, when we add in the worker groups, we also specify the exact amount of memory, pretty standard, and also some tolerations because unfortunately I have my project pretty young and I still need to fight with this stuff. So let's see how our container is living. Let's see the status of our array cluster quickly. Yeah, you see our cluster is started. We have amount of CPUs, amount of memory, and let's see if our REST service is also up. I'm curious if it's working. Okay, it's still restarting. Let's see what's happening inside of it. Because, you know, always when you do demo, you're nervous if it's actually gonna work or not. So what we see here, we see that we have normal schedule, everything was as expected, so we're gonna maybe wait a little bit more. Actually, on this point of time, if you're gonna test it by yourself, you can run into few issues. For example, it's also in a runbook, you can have a warning that the quota is exceeded, because GCP is extremely conscious about how much of NVIDIA L4 they are giving away. So you will need to contact the GCP team, for example, or if you're using another provider, you probably will also face with the same stuff. So just don't worry. It's not because you did something wrong. It's because the cloud providers are a bit greedy on how much they want to allow you to use their NVIDIA L2, for example. So it's also in the runbook again, so you shouldn't experience any issues on your side. Let's see, sounds good. Let's try to get our REST service now. Okay, we are waiting for server deployment. And before that, I'm also going to show you some fun stuff about our second resource. As you remember, when we're doing REST service, it's usually not only Ray itself, you also need a cluster basically to host all your model. And that's where you also need to configure it. As you see here, I'm using NVIDIA L4. Actually, this one is pretty weak. If you want some serious shit, you need to use, for example, TPU. It's the best stuff. Actually, GCP announced that recently that you can use TPUs. It's a new model and new stuff that is perfect for AI because it works a bit differently. If you want, you can also read it in the resources that I will share. It's extremely exciting part because of how actually machines works inside and how fast it read and write. So it's a pretty revolutionary, but if you want just demo stuff, you can still do NVIDIA L4. So I hope sincerely that we now finally have our stuff done because I extremely want to show you the generation already. And yes, our service is pretty and ready. So let's first of all receive our nice post port forwarding because I wanted to assess my fine and awesome model because it's now deployed. And I wanted to, of course, send some questions to it and send some pretty picture in the end. So here we are. We have our awesome port forwarding. And let's do our nice curl. So what we're gonna do, honestly, we can do whenever we want, and maybe I even can ask audience, but I trained this model only on cats, so that's only what it can do. So we're gonna try to receive the cat that does happy dance. Hopefully it won't be bloody stuff. Okay, it's still not connecting. Heartbreaking. You know, like usually when you do a live demos, it's extremely scary because you always can run out into a situation when it's so slowly. But before we are waiting, I can show you some examples that I was playing around before. And that's you see the progressing of the model. So here you can see some cat with a small fruit on it. You have this pretty cat that I usually receive from Stable Diffusion. Also you have smiley cat. And in the end, it's my personal triumph because you see cat is nice, it's looking well, it's looking like it's ready to the fight, it was the best one, and I sincerely hope when I will run this test, it will look in better even. But then again, my model breaks, so you see it still needs a lot of stuff to be applied. Basically, if I would train it on something bigger and something more reliable than NVIDIA L4, maybe it would be even quicker and nicer. So be mindful what you use for training. So running, awesome, finally. I'm so happy that I don't need to embarrass myself and wait even more to see the cat finally dancing. So let's do, okay, again, cannot connect to the server. Let's see, our Stable Diffusion is running. Let's do again a port forwarding. Stable Diffusion service should work perfectly. Okay. Oh, finally, yes. And actually, it's quite quick. I expected it to be less quick, but again, because of distributed processing and because I can scale up to 5 nodes, that's why it's good. So let's see, our image probably generated, and we need to find which one was new. Oh, no, this one. We unfortunately see only butt of the cat, but it's still pretty nice. I mean, like, it looks like a cat, it looks like something could actually happen there, so it's really interesting and nice. Let's try one more time. Maybe we will see face of a cat. I want to have it more pretty. And of course, let's wait. So one more time. Okay, that's even, some vibe in letters. I didn't thought it that, but probably it's also tried to run Italian as me. But anyways, looks good. Now also in this runbook you can find how to short it down so you won't have issues with the pricing because of course it's not cheap unfortunately, but let me tell you that using Kubernetes when you are scaling yourself, it's much more cheaper than using Vertex. I think for the few months I managed to benefit in 1,000 euros, so it's quite a lot because I'm doing NLP mostly and I'm working mostly with a lot of text data, and I can say it's definitely beneficial. So for example, if you want to also have some nice examples from GCP, you can also start with Jump solution. You can also look into how the GCP recommend to do it, or you can have a more detailed overview with workshops that I also did before on this QR code. So please feel free. I think this presentation will be shared. This resources is kind of helpful if you want to start your journey. And it's actually the end of it. So you can see the feedback and QA QR code and also my LinkedIn. If you ever had some questions or uncertainties, please feel free to ping me. I'm usually quite happy to answer. And you can also send me pictures of the cats that you're gonna do when you're gonna do the workshop on your site. So I will be extremely happy. Yes, thank you everyone. So if you have any questions, we'll be happy to answer them.
That was the cutest presentation I've ever seen. I love that.
Oh, thank you, thank you.
We do have some minutes actually for questions. Any question for Kateryna?
Awesome, we have a question, it's really nice. I was a bit scared for a second. I was looking in audience, nobody raising the hand, and I'm like,
So thank you so much for your talk. I would just like to know if you tried, instead of Ray, Kubeflow, if you had the opportunity.
Yes, I looked into it as a first option, but must confess what really excites me about Ray is that it was on hype. Additionally, and also that Ray, they suggest that they cover all the processing. So as you see, they help with the training a lot, and they help with data a lot, and that was exactly what I'm looking for. And I was interested into looking into one tool, learning it, and then adapting my model, because as I said, I wanted everything in one day. With Kubernetes, unfortunately, it's not this simple. You need to invest some time and looking around, but Ray is exactly like for this option when you need something quick and preferably flexible.
So you would say it's simple, like to bootstrap, like to start from zero.
Yes,
Cool.
exactly.
Thank you.
Thank you for your question.
Any other question? Remark, comment? Well, then, thank you so much, Kateryna.
Thank you, everyone. It was a pleasure.